This is a group theory question. We have been given a group G that has the order 6, and we also have H, which is a subgroup of G that has order between 1 and 6. The boundaries are excluded in this case. So based upon this information, we need to comment about the cyclicity of both G and H. So how can we do that? For this, we have the Lagrange's theorem, which says that the order of a subgroup always divides the order of a group. So if H is the subgroup of G, then we know that the order of G is 6. So what are the possible orders for H? 1, 2, 3, 4, 5 and 6. But they have already said that it lies between 1 and 6. So the boundaries are excluded. Also, the order of subgroup must divide the order of group, which means the order of H must be divisible by 6. So 4 and 5 are also excluded. Only 2 and 3 are the possible orders for the group H. So now, how can we comment on their cyclicity? Using the second theorem, that every group having a prime order is cyclic. But vice versa of this statement is not true, that if the order is non-prime, then we cannot say that it is not cyclic. In case of non-prime, it may or may not be cyclic. Both are possible. So as we can see over here, the order of group G is 6, which is non-prime. So G may or may not be cyclic. We cannot say for sure. But in case of H, both of its possible orders, 2 and 3, both of them are prime, which means H will definitely be cyclic. For G, it may or may not be cyclic. We cannot directly say just by looking at its order because it is non-prime. So the correct output will be G may not be cyclic, but H will definitely be cyclic since it has a prime order. For G, we cannot comment. So the correct choice to go would be the second option.